Gold, silver and copper were amongst the first metals to be discovered. They can sometimes be found as pure metals in the Earth's crust. These sparkles are tiny pieces of pure gold. And the diagonal ridge in this rock is a vein of copper. But finding metals in their pure state is rare. Copper is usually found in rocks, combined with iron, sulfur and oxygen. This is copper oxide. To extract pure copper metal, oxygen has to be removed, a process known as reduction. One method is to use hydrogen as a reducing agent. Hydrogen gas from a cylinder is passed over the copper oxide. A mixture of hydrogen and air is explosive, but once all the air has been pushed out of the tube, it's safe to burn off the excess hydrogen. It burns so cleanly that it's hard to see the flame. Heat the copper oxide in this atmosphere of hydrogen and it quickly changes colour. Hydrogen reacts with oxygen in the copper oxide to form water. Copper metal is left behind. While the copper oxide is reduced, the hydrogen is oxidized. But as soon as the hydrogen and heat are removed, the reaction reverses. What's happening to the copper? Carbon is a much safer reducing agent. Mix it with copper oxide and simply heat in a boiling tube. Carbon reacts with oxygen in the copper oxide and solid copper forms. Carbon is more reactive than copper. It's able to remove the oxygen and form carbon dioxide. While the copper oxide is reduced, the carbon is oxidized. So, can other metal oxides be reduced by carbon? A mixture of lead oxide and carbon is heated strongly for several minutes. Beads of pure molten lead form in the tube. But heat a mixture of iron oxide and carbon, and nothing happens. Why does carbon reduce copper and lead oxides, but leave iron oxide unchanged?